Hi, this is exercise 11A. It's a PowerPoint which is designed to make sure that you can answer questions on the, I think I've got a pen now, yeah I have, answer questions on the sine and cosine rules eventually, but in this one we're going to look first of all at the sine rule. Now the sine rule is something you've seen in the past at GCSE, so some of it should be fairly straightforward. I need to try to use a bit of old maths, I suppose, as well. It's not exactly a proof, but it's like a demonstration that it works. We have here a formula that you should remember from GCSE as well. This is at the area of a triangle. We will come to this quite a lot, so you don't forget that. The area of a triangle is a half AB sine C. And we can say that is true in a number of different ways. Obviously, if I use this angle here, it's a half of AB sine of the angle in between, so half AB sine C, which is what I've written there. But if I was to use this angle, it's an angle of a half of BC times the sine of angle A. BC sine of angle A, that's this one. And if I was to use this one up here, the full angle, of course, the area would be a half of AC times by the sine of the angle in between, sine B. So you've got three equivalent formulae which all basically find the area of the same triangle, so by definition they must be the same. Now the proof then relies on that fact. The area of one, this half AB sine C, is equal to this, is equal to this. That's basically the idea. Double everything. AB sine C equals BC sine A, AC sine B, all the halves have gone. And then we can divide all the way through by ABC. Now if I divide this by ABC, it's already got AB, but it hasn't got a C. So it ends up being sine C over C. And likewise, these have a letter left at the bottom as well. So sine C over C is sine A over A, sine B over B. And that basically suggests that it doesn't matter which two sides you're playing with, which two angles you're playing with. It could be C and A, it could be A and B, or B and C. You can always use this sine rule. So that's what the sine rule says. I tend to only ever write these first two. And so when you see me do it in a bit, I'll just write the first two. But in the textbooks, in the former books, you always get three of them written. So anyway, not in the former book. Oh, there you go. It used to be in the former book. Obviously, they got rid of it. So you'll need to learn it, okay? But you probably should have done from GCSE anyway. If you know one side and an opposite angle, and you want to know one more side or one more angle, effectively you can do it. You need three of the four things to be able to do it. And that the unknown thing I'm going to show you. There's two versions of this, really. To find an angle, we tend to put the thing that you want, you put on the top of the equation and the left of the equation. So I've written sine A over A equals sine B over B. That's if I want the angle A. But if I want side, notice now I've got A at the top, little a. So A over sine A equals B over sine B. And you can do that. You can just do the reciprocal of them because it just rearranges quite nicely. So I tend to find if I want an angle, I use the first one. If I want the side, I use the second one. So let's have a go at this question. It should be fairly straightforward. I've got to find my pen. There it is. So first of all, you just got to make sure you've got everything you need. Sometimes they're not in the right places and you've got to do a bit of work first. But it says in this triangle, we want to find the angle A and C. Now one of them, it's actually this one, which is easiest to find. And that's because I always think of this as opposites. You see, you need two pairs of opposites. So I've got the 12 is opposite 62, I've got the 10 is opposite the A. So because I'm going to try and find this A first, I'm going to write sine A over the A. What is the one opposite A? It's 10. And that is equal to, now I've written sine at the top, so I'm going to write sine at the top. And the other angle I've got is 62. Happens to be B, but it didn't have to be. I would have just used it anyway. And sine 62 over 12. Now I rearrange that, I get sine A equals 10 times by the sine 62. And basically that thing always moves over and becomes a times divided by 12. So if I type that into my calculator, it's 10 times sine 62. You better make sure you close the bracket or press equals divided by the 12. And I've got 0.7 3, 6. Now bear in mind this is not what A is, this is sine A. So sine A equals 0.736, and leaving that on the screen I can inverse sine that number, and that gives me 47.4. So that's one angle. And of course, to get the third angle, you could do the same trick, but really all I need to do, 180 minus the 62 and minus the 47.4. So I'm going to do 180 minus 62 minus the answer I just got, and I got 70.6. So this angle up here, C, you don't have to do it all again. You could do that if you prefer to, feel free, but certainly quicker just doing that. So answers 47.4 and 70.6, and that method was the same as mine. So let's have another go at this one. It's called XYZ, but really I don't care about that. It says find the length this time, the length of XY. Now where's it? XY is over here. So again, you'll notice I've got two pairs of opposites. They're not always in these places, but these first two examples have been. I want a length this time, so I'm going to use this formula. So I'm going to write XY over, now it's opposite the 55, so I'm going to write sine 55. And that is equal, I put a length on the top, so I need a length on the top, 13 over sine 29. And I do the same trick, this thing moves over, I get XY equals 13 times by the sine 55 divided by the sine 29. Again, I type it into my calculator. I've got the advantage of this time it will equal it. I won't have to, don't forget your bracket either. I won't this time have to inverse sine because I don't want an angle. It just says 21.96. So XY equals 21.9, well 97. Doesn't say how accurate. Normally I'd round that, so I'm going to call it 22.0 to 36 figs. I don't know what my answer is. 22.0 to 36 figs, there you go. Obviously centimetres and stuff, you'll need to do those. Now sometimes they don't draw them for you, you've just got to use your brain a bit. So let's have a go. Let's draw a triangle. It doesn't matter how you draw it particularly. Label them A, B, C. There you go. B is 3.6. Now B of course is opposite the B. That's 3.6. C is 4.2, so that's opposite the C, 4.2. Angle C is 110. Find the size of angle B. Now the one I can find easily is this B up here, because we're playing this opposites game. We need two pairs of opposites. So again, I'm just going to go sine B over the 3.6 equals, so I had an angle on the top, so I shall keep an angle on the top over 4.2. So just rearranging that, I'll do it on my calculator, but I'll talk you through it and type it in at the same time. So it's 3.6 times sine of 110. Obviously hope you're in degrees, otherwise none of this will work. Close the brackets, divide by the 4.2 equals, and I get this is 0.805-ish. And obviously that's not what I want. I want B, which is the inverse sine of 0.805, and therefore inverse sine of the answer equals 53.7. And again, last time I wanted it to 36 figs, so I'll keep the same thing here, 53.7 degrees. Oh yeah, I forgot to find the other angle. Of course, the other angle is angle A, and I'd use the same trick, 180 minus the 53.7. And what was the other angle? Oh, it was 110 in here, minus 110. So minus 110. And that is 16.3. So we're getting there. Let's see. This one I'm going to leave you to draw. You're doing the same trick. Draw the PQR and then see if you can find it. The angle should be 10. You'll know if you've got it right. It's a side, so it's a slightly easier version, I think. Now the ambiguous case is something I want to just make you aware of. So here is a question which basically says, look, I've got this line A to B. So we've got some point over here, the edge of a circle, and I've got the centre of a circle, and that distance is 10. And I draw a line from that A point, which you can see hits the circle in two places. Now the weird thing is, because it's a circle, this distance and this distance must be the same distance. Do they tell me? Yeah, they tell me that it has a radius of 6. So because it's got a radius of 6, it could be that little triangle, or it could be that big triangle. And in actual fact, I don't know which one it is. Could be either. So you've got the potential, if they give you certain information, you won't really know which one of these it is. You know, it could be, for instance, say I'm asked to find this angle. It could be that angle. It could be this angle. It could be either. And so just bear that in mind. We call it the ambiguous case because there's two possibilities. So we've go through this quickly. We'll just show you this in action then. So if this is my 30, you can imagine this is drawn for me. This is my 30. This is opposite this one. Perfect. This is my 10. It's opposite the C. Do they tell me the C? Let's see what it says. Find the angle. Oh, it wants me to find the angle C. But it's opposite. So everything seems good. I write sine C is the one I want over the 10 equals sine 30 over the 6. So everything perfectly reasonable. Sine C equals 10 times it. So I'll move it over in time. So it's 10 times sine 30 and divided by 6. I've got 5/6 on my calculator. And of course I'm going to inverse sine. Inverse sine of that. No idea what that is. Sine of the answer is 56.4. I'll better write 5/6 there. And it's 56.4. So you just look at that picture. Actually, which one do I think it is? I think I found that one. That's the one that looked like 56.4. But I did say to you it could have been this one. And the reason for that is, do you remember with sines? I've said that if you get sine and you're doing sine and you get theta, you get another solution at 180 minus theta. Now, sometimes when you have small angles in a triangle, there's a potential, if you're not careful, of having two potential answers. You don't know. So in this particular case, yeah, I just need to check. So if I do 180 minus the 56.4, it's a minus on this. I'll just do it on my calculator. It's about 123, I think. 180 minus the 56.4, and it should be, yeah, where is it? 123.6, of course it was. So 123.6, if you just think about it, you really should do this every time you do a question, but most of the time it doesn't come into play. But that 30, if this was 123.6, I know it doesn't look like it, but if it was, that would be 153. There would still be an angle down here, which, you know, that kind of works. Sometimes when you do this, you get an angle here which is, say, 123.6 like this one. But if this was, say, 95 degrees, already there'd be too many degrees in the triangle. So sometimes it doesn't work, and therefore it's not a problem. But there are occasions when it does cause problems. So this should give, yeah, there's the two angles that I was referring to. In an exam then, very quickly, I'll just try to do this. It says draw a triangle PQR, so I'm going to quickly draw it. There's my PQR on this. It says angle P is 37. Oh, that's a P. So there's my 37. P, it says, is 5. Let's label this Q and R. R is 7.2, so that's 7.2. And what's it asked me to find? It says find the angle, find two possible values of R. So if I just quickly try to do this, obviously, as I was saying, you know, I've gone quickly down through the maths because I've run out of time, but you can see I've done the question, I've got this 0.866 for it, I've inversed it, and I've got 60.1. Now, the thing is, 37 and 60.1 is small. So I've quickly written all this on. You got 60.1. I found 180 minus it to get the next answer, and then found the Q. So just be aware then. I want you to do these questions. Page 207. Have a go at them. Exercise 11A, and good luck.